Hello again. I'm going to go over 3 of the sections in your calendar. Let me show you. So I'm just going to go over these sections here today and do some of the problems in Newton Alpha. In the next video, I'm going to go over these sections. Okay, so let's just start. First, I hope you're still doing well. And remember, eat lots of vegetables and fruits. The body is the best way to protect yourself. So make sure your immune system is strong enough, and that will work for you. All right, so let me get rid of my video because I don't need to take part of the screen. So let's talk about the first section, which is law of sines. Now, you have heard of Pythagorean property already, and Pythagorean property says that if you, let me restart this quickly. Let me get it back. I closed it, my mistake. Let me get it back. All right. So, there you go. So in Pythagorean property, we worked with only right triangles, but now we want to extend that to any triangle. So, of course, the first concept is the law of sines, which is this right here. And with the law of sines, we find a relationship between the 3 angles of a triangle and the 3 sides. So with Pythagorean property, if you have a right triangle, we can find the sides and the angles if we have enough information. But now we want to work with any triangle. It doesn't have to be the right triangle. How are the sides and the angles related if you have any triangle? So that's what this section is all about. So let's start by looking at the law of sines. First of all, if we have enough information about the triangle, then we can solve the triangle. By solving the triangle, we mean finding all 3 sides, the measures of all 3 sides, and the measures of all 3 angles. Now, what is enough information? Well, enough information means at least 3 of them are known, and at least one of the known quantity has to be a side. So at least one side. So we cannot, basically, we're going to exclude the 3 angles. So if we know 3 angles of a triangle, that doesn't mean we can find the other 3 sides. The reason is that there is more than one angle possible, or one triangle possible, if the 3 angles are the same. You see, all of these triangles have the same 3 angles, but you see, these angles are the same, these angles are the same, right? So just by the fact that we know that 3 angles are the same, that doesn't mean that we can actually find what the other 3 sides are, because 3 angles don't determine a triangle. Now, so we have to have at least one side given. At least one side means either 1, 2, or 3, right? And depending on what information we are given, we can use 2 different laws here to find the measures of the unknowns. And the 2 laws are the first one is the law of sines, and the second one is the law of cosines. Now, all of these right here, all of these we can find with the law of sine. But if we have situations like this, the law of sine doesn't cut it, and we're going to see why. So if we have two sides and an angle that is not between them, that's fine. That's enough information to solve the triangle. So basically it means two sides and the angle that is not between them, like for example this angle. Then we can find the other side and the other angles, and we are done. Now, what if we are given two angles, and the side between the angles? That's fine too. Then we can just find the other two and then find the other angle. What if you're given two sides and the angle between them? Then yes, we can find the other side as well. And what if you're given just three sides? Well, yes, then we can find the three angles. All right, so that's what we want to do. So let's start with law of sine. So law of sine says that if you have a triangle ABC, so our notation here is going to be, when you want to draw a triangle with ABC. So draw a triangle and name it like this, ABC. Now you don't have to do that, but that's a good convention to use. And then ABC are the three vertices. Usually the angles are different from the vertex, because at the vertex you can have more than one angle. But in these two sections, I'm just going to consider the angle to be the same as the vertex. But here you're going to see in the shapes that I have here that the angles are named differently from the indices, from the vertices. So here alpha is the same as A. So when we draw a triangle and we call it ABC, then alpha is the same as angle A, beta is the same as angle B, and gamma is the same as angle C. And the side across from A is called A, lowercase a, and the side across B is B, and the side across C is C. If we stick to this notation, then we don't get confused. All right? So that's how we are going to name the triangles. Now, if you look at this, triangle here, notice that if we draw a perpendicular from any vertex to the base, let's say from B to the base AC, perpendicular, that triangle right here is a right triangle. So that means that the H here, which is this side, you look at this triangle right here, H here, the sine of this angle, alpha, so sine of alpha equals to H divided by hypotenuse, which is H over A. Also sine of gamma, this is gamma. So sine of gamma equals to H divided by A. Now sine of alpha here is H divided by this hypotenuse, which is H over C. Now here, H, if you cross multiply, H times 1 equals to A times sine gamma, right here, and then cross multiply here, you get H equals to C sine alpha. Now, since H's are the same, we can set these two equal to each other, and we do that here. And then if you just put the sine alpha under A and put the sine gamma under C, that's the same thing, right? Because if you cross multiply here, you get this, right? A times sine gamma equals to C times sine alpha. All right, so this relationship between the sides and of the angles is true here. Now, if you do the same thing for this vertex right here, and then call this one H, and go through the same process, you're going to find another expression relating the sides and the angles involved. And if you draw a perpendicular here and call this one H, and then go through the same process, you're going to find another expression that relates the angles and the sides involved. And if you put them all together, we get basically this relationship between the angles and the sides of a triangle. So law of sine says that if you take any angle, take sine of it, and divide it by the side across from it, that's equal to take any other angle, sine of it, and divide by the side across from it, equals to take any other angle again, take the sine of it, and divide by the side across from it. So that's what this is. You could also take a reciprocal of these and get this expression here. So sine A, and notice that I used the A, B, C for angles. You could also use alpha, beta, gamma, but from now on we just try to use A, B, C unless we are given alpha, beta, gamma. All right, so that's what the law of sine is. So let's do an example. Solve the following triangles. Give exact answers in decimal approximations rounded to 100th and sketch the triangle. Okay, so you see we have to draw a triangle, and the good thing is a good convention is to just draw what? A triangle ABC, like this. And then alpha here is the same as A, so it's 120. And then A, which is the side across from A, alpha, or capital A, is 7. And beta is 45, right? And that's all we have, right? We don't have any more information. Okay, right away you can see that we can actually solve this because we know this angle, so that would be sine of 120. Sine of 120 divided by 7 has to be the same as what? Sine of 45 over B. Sine of 45 over B. And if you cross multiply here, what do we get? Well, we get B is going to equal to 7 times sine 45, 7 times sine 45, divided by 7 times sine 45 divided by sine 120. And that's our B. Once we have B, well, we can also use the same setup that we had. We can also use it for C and find C. And then since we have these two angles, we also have this angle because they add up to what? 180. So you see, we can solve the triangle. All right? So that's how we can solve the triangle. So let's look at the work. So here is, you don't have to, when you draw a triangle, it doesn't have to be the correct scale. So it doesn't matter as long as you name it correctly. Okay? So in this case, this is C, right? This is C, because C is here, and this is A, and this is B. That's how we draw it. Now, of course, this is drawn afterwards that we know the angles are, how big the angles are. In my picture, of course, I drew it like this, and I said this is 120. Well, obviously, it doesn't look like 120, but we do that just to be able to do our calculations. It's very easy to, it's less confusing if you do it that way. Okay, so here is the triangle. So as I said, we set up our the three ratios, and notice the ratios have unknowns in them. So basically, if you set up a ratio like this, you can solve it because there are 1, 2, 3, 4 unknowns, and one of them is missing. then you can solve it. Now you could also do it here. There is 1, 2, 3, 4 unknowns, and then one of them is missing. Then you can solve it. All right? So here b equals to 7 times sine 45 divided by sine 120, which I have it over here on the calculator. Right? 7 sine 45 divided by sine 20. Now you got to make sure that you have your calculator mode has to be in radian, otherwise it wouldn't work. Your calculator mode has to be in radian, so make sure you go to your mode and change it to, not radian, degrees, because the angles we are given are in degrees. So basically what you want to do is 7 sine 45, and you can press enter, and then divided by sine 120. There. So we know that has to be 5.72 if you round to 2 decimal places. And then how do we find c? Well, c is going to be 7 times sine 15, right, is 7 times sine 15 divided by sine 120. You can do it again here. 7 times sine 15, and then divided by sine 120. So that's 2.09. So that's c. And then alpha, gamma, the angle c or gamma is easy to find. All you have to do is add the 120 plus 45 and subtract it from 180. You're going to get a negative answer, but it doesn't matter. Still, it's 105. Not 105. I did minus, sorry. 120 plus 45, and then minus 180. 180 minus the answer, so it's 15. So you see, we actually solved the triangle. That means we found the sides and we found the angles using the law of sine. Okay? So here's another one. Solve the following triangles, give the exact answers, and decimal approximations rounded to hundredth. Okay? Again, we can draw this a picture for this. We have two angles and we have a side, right? So let's say this is, let's call this B, we call this A, we call this C, right? So we have a triangle A, B, C. Then what do we know? We know alpha is 85, so this is 85, so we'll put it here. And then we know beta is 30, and this is 30 right there. Now right away we know that this angle is 65 because 180 minus 30 minus 85 is 65. Okay, so we need to find, so we're given C, we're given this one. C is across from angle C. So we're going to find A and we're going to find B, right? And again, to do that, we first write the three ratios that we have. Sine A, which is 85, divided by A is the same as sine B, which is 30, divided by, sine 30 divided by, B, which we don't know what it is, and then equals to sine 65 divided by C, which we know is 5.25. Okay, so now from these ratios, we can find the unknowns. Can I find the unknowns from this? Yes, because there's only one unknown. Can I find the unknowns from here? No, because there are two unknowns here. So I can find B here, then use this one and this one to find A, right? This way we use the numbers that we are given, so we're not doing any rounding. right? So that's all there is to it. So if you use this one right here, if I use this, then B is going to equal to 5.25 times sine 30 divided by sine 65. Sine 65. And again, you have to make sure your calculator is in degree mode, and so we do 5.25 times sine of 30, enter, and then divided by sine of 65. So 2.8, 2.9 maybe, if you round it. Okay, now we can take sine this one, we can take this one and this one. So sine 85 over A equals to sine 65 over 5.25. Now cross multiply again. So A equals to 5.25 times sine 85, enter, divided by sine 65. Sine 65. And that's 5.77. So now we have all three unknowns here. 3 of them were given and 3 of them we figured out. All right. And here's another one. Solve the following triangle, give exact answers and decimal approximation. Okay, so we try this one and something interesting happens. You see, if you draw this, let's say we draw a triangle, right? Complete triangle. And we're going to call it A and B, C. So we are given alpha, which is this angle right here, is 30. And then we are given A, which is the sine across from it, is 1. And then we're given C is 4, across from angle C is 4. And that's it. Now, can we solve this? Well, we're going to see, we're going to set up the ratios and see if we can solve it. When we set up the ratios, we're going to get these, right? All right, so let's use this one to find sine B. Now, there are two unknowns here, so we can't do it. Now, what about this one and this one? We can do sine 30 divided by 1 equals to sine C divided by 4. So now the unknown is sine C. So sine C times 1 equals to 4 sine 30. Now, what is 4 sine 30? Now, you know, sine 30 is 1/2. So if I took 4 and multiplied by sine 30, obviously I get 2. So this says that sine C equals to 2. Does that make sense? Well, no, because if you try to find the sine inverse, because you see, to find this we have to write C equals to sine inverse of 2. Well, that doesn't make sense because the domain of sine inverse can't be 2. So you get an error message. Now, what does that mean? Well, it means that such triangle is not possible. It's not possible to have a triangle with the sizes of the angles and the sides that we are given. It's just not possible. And this happens if we are given two sides and the angle that is not between them. So if we are given two sides and the angle is not between them, either we write it like that, which is the name of an animal, we don't want to use that, so we just write it like this, right? So that creates a situation, we call it an ambiguous situation. That means there could be no triangle possible, there could be one triangle possible, there could be two triangles possible. And it depends on how big this side is. If this side is exactly the same as the vertical distance here, then there is only one right triangle possible. Now, if that side is exactly this, then we have one right triangle possible. If that side is a little bit bigger than that h, then there are two triangles possible. One of them would be obtuse and one of them would be acute. So there are two triangles possible because the side could be here or it could be here. Now, if this side is bigger than this vertical distance and is bigger than that, then there is only one triangle possible, and that would be that one. Because you cannot put this on the other side because it's bigger than the side C. So you're going to go outside of this triangle to build another one. Okay, and we're going to see that in a moment. So whenever we have two sides and the angle that is not between them, then we have the ambiguous case. So there are four possibilities: no triangle, one right triangle, two triangles, or one triangle that is not the right triangle, just oblique triangle. All right, so in this case we have no triangle. So what if we have the same situation, and this time this is 2? Well, now whenever we have this situation, we can actually find this distance h. So suppose our triangle looks like this, right? And we're going to call this one A, 2. This is A. So this is A again. This is B. This is C. So we're given that A is 30 and side A is 2 and C is 4, and that's it. Okay, now if we draw a perpendicular to this side and call it H, but what is the value of H? Well, we know that the sine of 30 is going to equal to H divided by what? By 4. So H has to be 4 times sine 30. But I know sine 30 is 1/2, so you know H is 2. But the side A is also 2, so that means this side is actually perpendicular like that. So there is only one triangle here is possible, and that triangle is actually a right triangle. So, and to find it, of course, we can use the information that we are given. So if we set this equal to this, we can find angle C. So angle C would be what? Well, let's see. Sine C equals to 4 times sine 30 divided by 2, right? If you cross multiply here. So that means, use a calculator. So that means sine C is 4 sine 30, enter, divided by 2, which is 1. And what is sine inverse of 1? What we know is 90. So that means this angle right here is 90, right? Remember that was C, A, B, And that if that is 90 and this is 30, that makes this one 60. And then we can also find b. So if you want to find b, we can, now that we know what angle b is, we can use this. So we can say sine 30 over 2 equals to, I'm writing too big because my stylus is so big. Okay, so sine 30 over 2 is the same as sine b, which is 60, because we know what it is, divided by b. So again, cross multiply to find b. So b is going to be 2 times sine 60 divided by sine 30. Sine 30. So 3.46 something. That's the that's that one. Okay. So we got the triangle solved. All right. So that's the idea I was talking about. Problematic case or ambiguous case is basically when we have two sides and one angle given, right? And as you see over here, you don't have to memorize these. You could just draw this picture here and think of this as A, and think of the vertical distance to be H, right? So let's let me do this again. So think of the vertical distance to be H, and this is your A, right? Obviously, if A equals to H, we end up with a right triangle. If A is smaller than H, there is no triangle possible, right? If A equals to H, would be right triangle. Smaller than H, right? This is H, so this is A. And then if A is bigger than H, but is smaller than what? Smaller than C, then there are two triangles possible. One would be here, one would be the other side. All right, so notice that this one would be an obtuse one. And if A is bigger than H and bigger than C, then the only one that is possible is the one that we put right there. Because if I draw this on this side, I go outside of the triangle, so this angle wouldn't be part of the triangle anymore. So that doesn't work. Okay? So one right triangle, one oblique triangle, one no triangle, or two triangles. Two triangles. Okay? So here's the case when we have two triangles. So in this case, our A is actually 3. So again, this is A, B, C. Now, when we set this up, we know sine 30 over 3 is the same as sine B over B, sine C over 4. Now, when we set sine C, so sine 30 over 3 equals to sine C over what? Over 4. So that means sine C is going to be 4 times sine 30 divided by 3. So let's see what that is. So 4 times sine 30 equals to 2 divided by 3 equals to 0.66 something. Now that is what sine C equals to, right? That's what this sine C is equal to. So C is going to be sine inverse of the answer, sine inverse of whatever that is. And that would be 41.81. But that's not the only answer, because if a sine of an angle is, 0.6 something, it could be this angle, which is 41.81, but then it could also be this angle, that one, which is basically 180 minus 41.81. So let's do that. 180 minus, for the answer. So 138.18. So as you see, there are two possible angles here. It could be 41.8 or it could be 138.19. And we have to take those separately. First, we consider that to be 41.8 right there, and then find the other two sides that are missing, the other unknowns that are missing. Then we consider it to be 138.19, and then solve it like that. Okay? So first, for example, let's say we consider that. If we have this, that means this angle right here is 41.81. Now, it's easy to find the other angle because, well, we can add these and subtract from 180 and we get that one. So that's that angle. So the only unknown here is B. And we can either find it this way or we can find it this way. Right? So B is going to equal to, let's do it here. So B is going to be 4 sine that angle 108.19, enter, divided by, see, so it would be 4 times that, divided by sine of 41.81. So sine of 48.81. So 5.7 something, right? That one right there. All right. Now we're going to do exactly the same thing, except this time we are going to assume that the angle is that. So C is that angle, right? If C is that angle, then the other angle would be this plus 30 and then subtract from 180, we get that. So that would be B, and that would be C. Now we find B using those numbers. And then if you do that, you get 1.23, which is right there. Okay? All right. And all right. Now here we have another example where this time A is 4, and notice that it could be greater than or equal to C. If A is greater than or equal to C, then we would have only one triangle. If I take this and put it on this side, I don't make a triangle. It just goes over this. Now it's bigger. If it's bigger than 4, then it goes over there. That triangle is not what we want because it doesn't include this angle, right? So in case that side is bigger than H and also bigger than C or equal to C, then we're not going to have two triangles. We're going to have one, and that is the one. So to do this again, we're going to set this one. Oops. We're going to set this one. What am I doing? I didn't have the pen. There we go. So I'm going to have this equal to that and find sine C. And in this case, you're going to see that sine C is going to be let's see. So I have to take 4 and multiply it by sine c, sine 30 I mean, and then divide it by what? By 4. So that would be sine c, right? So this times that, and then divided by 4. So sine c equals to 0.5, so that means c is going to be what? C is going to be sine inverse of 0.5, which is 30 degrees, right? Now, of course, you say, okay, well, there is another angle too, but it doesn't work in this case. You see, this is 30, so the other angle that has that sign is going to be 150. But can the angle be 150? No, because we are given what? We are given this one is 130. I mean, this is 30. And if the other angle, if this one is 180, 150, then we have nothing left for that angle, right? So that means in this case, we don't have two triangles, we only have one triangle. And that would be the one that you see right here. Okay? All right, so let me show you an animation right here. Let me turn off that. So that's the idea of the ambiguous case. Let me wait for it to download. So you see right here, this side right here, if it's shorter than h, notice that there is no triangle possible, right? If it's equal to h, then there is only one possible. Now if it's bigger than h, then we can have, let's say it's this big. We can have this one, or we can have this one. But if it's bigger than h and bigger or equal to c, then let's say if it's this big, well, that triangle doesn't work because that angle is not part of it. So the only triangle would be something like this. So I can't put this on the other side and make a triangle. So those are the different situations that we're going to have if we have the ambiguous case. And you see the pictures here. You can stop it and look at it. All right. So now, what if we are given two sides of a triangle? If we are given two sides of a triangle, and we are given an angle that is between them. So if you have two sides and you have this angle, let's say this is A and this is B. Now, remember the way that we name these things, if this is A, then this angle is A. And if this is B, then this angle is B, right? And then this would be C, right? So that means the angle has to be called C. So if you have two sides and the angle in between them, and the way you can tell that is between them is because it doesn't go with these two letters, right? It's in between. If you have this, then finding the area of this triangle is really easy. All you have to do is just times 1/2 this side times this side times the angle between them, between the angle of the sine of the angle between them. And you can easily prove that if you put h here, if you draw a vertical here, h, you can easily prove this because the sine of this angle would be h divided by this side, right? So you can easily prove it. So in a right triangle, notice if you have these two sides, let's say we have B and we have A, and this angle right here, which is going to be C. Now if I draw this H here, I know the sine of C equals to H over what? Over A, right? Now, so H is nothing but what? A sine C, right? So A is basically A sine C. Now, so instead of C in this formula used gamma, but this is C, this is B, and this is A, right? It doesn't matter, they're the same. So how do we know, what do we know about the area of a triangle? Well, area of a triangle would be 1/2 base, let's call this base, times the height, which is h. But we know what h is. H is what? A sine C. So if you substitute for h, A sine C, you get these formulas, right? That's all there is to it. That's the proof of it, if you wanted to prove. But remember, it's easy to remember, this is, if this is B and C, this one would be A. If this is A and C, this one would be B. If this is A and B, this one would be C. And you can easily find the area. Here you go. You're given an angle, 120. So alpha, or A, is 120. A is 7, and beta is 45 degrees. Find the area of the triangle. So we are given, in this case, we are given two angles and one side, but we can still find it. So let me just draw it quickly, since we can find. So if we draw it, where is my pen? So if we draw it, let's call this A, B, C. So what do we have? We have A is 120. Remember, A is the same as alpha. B is 45. And then A is 7. So to find the area, all I have to find is this side, right? If I find this side, then I can use this side times 7 times the sine of this angle, and then divide by 2. But what is this side? Well, this side would be, we can find it because, or we can find this side actually. Well, let's find it. So A, alpha is 120, beta is 45, and then A is 7, okay? So 1/2 times 7, what is that side? Well, that side would be 7 times, what is this angle? If we have 45 and 20, that's 165, so this angle is 15. So sine of this angle divided by this is the same as sine of this angle divided by that, so I can easily find it, and you see it right there. So if you write it, x over sine 15 equals to 7 over, remember, you could take a reciprocal of these, but if you put sine in the denominator here, you have to put it there too. So 7 over sine 120. So if you cross multiply, x would be 7 times sine 15 divided by sine 120. And then the formula is 1/2, this side 7, right, times x, which is this whole thing, and then divided by 2. All right, and the answer is 5.18. All right, now we got to law of cosine. Now, you know about right triangle. So if we have A, B, and C, then in a right triangle, we know C squared equals to A squared plus B squared. Now it turns out that if the triangle is not a right triangle, then there is a relationship between the three, but you got to subtract here minus 2AB cosine of C. Now you see, this C is a little lowercase c, that c is the angle c, which in this case we put gamma here, but this is the same as c, and this is a, right? So is an extension of Pythagorean property to any triangle that relates the three sides of any triangle. So if I want to write a squared equals to, then a squared would be b squared plus c squared minus 2bc, that's the square, 2bc, and the cosine of this angle, which is a. If I'm going to write c squared, then c squared equals to a squared plus b squared minus 2ab cosine c. And b squared equals to a squared plus c squared minus 2ac cosine capital B. So that is the law of cosine, which is really useful. Now you can prove it this way, okay? You don't have to prove it, but you could. If you put the triangle here such that the angle A is at the origin, and angle B is on a circle, as in this circle with the radius c. This is radius lowercase c, and this is the point right there, right? Then the other side would be here. So that's B, this is A, and this is C. The only thing is that this vertex is at the origin, and this vertex is on that circle with the radius c. Now, from previous chapters, when we talked about unit circle, we know that the coordinates of a point on a circle, right there, is given by c times cosine of this angle for x coordinate, and for the y coordinate would be c sine of that angle. And the coordinates of this point right here, well, the x coordinate is just b, and the y coordinate is 0. So we got 2 points here and here. We can find the distance between these 2 points, which is a squared, right? Which is a. And then a c squared would be the square distance. So the distance is a distance formula. Distance formula says the distance between 2 points is what? Square root of something is squared plus something is squared, remember that? Would be x2 minus x1 over y2 minus y1. Now what is x2? Well, you have to name these 2 points. One of them is x1, y1, one of them is x2, y2. So if you call this x1 and this is y1, and we call these two x2, y2, then x2 minus x1 would be that. And then y2 minus y1 would be that. Then we square them. Now from there, there's just a little algebra that I'll let you look at this and figure out. It's not really that hard. If you look at the algebra, you see that a squared ends up being c squared plus b squared minus 2b cosine alpha. And if you just change these names, you get the same expressions for the other sides. It doesn't really matter, right? Because you can put any of those angles there. And that relationship exists for any side. Okay? All right, so let's use the law of cosine to solve triangles. So we got a triangle. Again, you always draw a triangle ABC. Now put the numbers here. B here is 50. Remember, B is the same as beta. A is 7. A is across A. And C is 2. All right, now, first of all, notice that the law of sines doesn't work. Because if you write the ratios, you're not going to be able to find the ratios, the unknowns, because we need another angle in order to be able to use the law of sines. It would be sine of b over what? This is missing. And then sine of what? Over 7. This is missing, right? Another missing. And then this is missing. So there's no way we can find it with the law of sines. But with the law of cosine, we can do that. with the law of cosine, we can find, you see, we have this side and we have this side and we have this angle. So we can find this side right here. So let's do that. Let me erase that and that and that. So we're going to call this b. So we can write b squared equals to a squared plus b squared, c squared plus c squared minus 2ac cosine b, right? So b squared is going to be 2 squared, 7 squared, 7 squared plus let me do it in that order. There you go. Let me do it in that order. So a squared, 7 squared, plus c squared, which is 2 squared, that's plus, minus 2 times 7 times 2 times cosine of 50 degrees. And that's it. So let's see what we did with the calculator. Don't forget you have to be in degrees mode. So 7, let me do this. So 7 squared plus 2 squared minus 2 times 7 times 2 times cosine of 50. There. And then we have to take a square root of the answer. So it looks like that's what we have, and where I am, and that's 5.9. That's the answer that we get. So now remember, our triangle didn't look like, they didn't have the correct scaling, but that's okay. Once you find all the unknowns, then you can draw a correct one. Okay, so that's how we use the law of cosines to find this side right here. And once we have that side, then we can go back to law of sine and find the rest of the triangle, right? So let's see. So in this case, again, we cannot solve with the law of sines only. We have to use law of cosine. All right, so here's the answer and the calculator. You can, again, go back to law of sines and then do the rest of it. All right, so I'm going to quickly go over this. You're not responsible for it, but, the Al-Biruni, this guy, Al-Biruni, what he did a long time ago was that he figured out how to find the radius of the planet. How did he do it? Well, he went and found the height of a mountain around him. So he found the height of a mountain, and then went on the top of the mountain and found the angle of depression between the horizon from the top and the horizon this way, and used that angle to find the radius of the planet, which is this radius right here, right there. Now, I have the, in the notes, I have this, and you can read it, but I go over it quickly just to see how trigonometry was used to find the radius of the planet. So let me erase everything. and go back. Okay, so basically to find the height of a mountain, you can just go stay some distance from the mountain and then find this angle, and then go further down closer to the mountain, find this angle, and then you can write equations for this h using the tangent of this angle, right? So this distance, this whole distance is capital D, and this is lowercase d, okay? So that means this part would be capital D minus lowercase d, right? So now tangent of theta 1 is h over capital D, right? And tangent of theta 2 is h over this side, which is d minus d. Now from here, if you solve for h here, h is going to be cross multiply. It's going to be d tangent theta 1. And over here, h would be d minus d tangent theta 2. So since these two are equal, we can set these two equal to each other, and then move things around until we can get capital D by itself. And that's the relationship between capital D and the two angles and the lowercase d. Now from here, we can find what h is. So h is d tangent theta 1, right? We get it from here. But we know what capital D is. We just found it, this whole thing. If you multiply that by tangent theta 1, we get a beautiful relationship, that expression, formula, that you can use to find the height of anything that is right in front of you. So you can go around and look at the tall building and just find two angles like that, and find the distance between where you start and where you read the second angle. And that's all you need. See, in this formula you need that distance and you need the two angles, and you can find the height of this thing in front of you. That's just an amazing thing you can do. Now what Biruni did, of course, he did this, and then he went on the top of the mountain and then found this angle. And he argued that this angle is the same as this angle. And of course, this part is the radius of the planet. Now, why is this angle the same as this angle? Because inside this right triangle, this angle plus this angle that let's call it O, and let's call this, X. So O plus X is 90, and alpha plus x also is 90, so alpha and O have to be the same. So that's the angle O, and then if you write the relationship between that angle and the sides of that triangle, you end up with a beautiful formula, and it's called Biruni's formula, which is that last one right there. And that says that what? That the radius that we're looking for is the height of the mountain times the cosine of this angle that you measure here, and divided by 1 minus cosine of that angle. That's it. That's how he found the radius of the planet. And he was pretty close, about 1% error, which wasn't that bad. So his estimation was about within 200 miles of the actual value of 24,902 miles. Now the device that he used is called Astrolabe, and you should check out the videos on Astrolabe. Astrolabe was the computer for centuries before actual computers that we use today were invented. Astrolabe was a really complicated device, and there is a link here to a video that talks about it. So one of the features of Astrolabe was, of course, to find these angles accurately, and that's what he used. All right, so there is another formula that is very useful. It's called Heron's formula, and that says that if you have just 3 sides of a triangle, you can find the area of a triangle. So just 3 sides, A, B, C, no angles. You can find the area of this triangle. How? Well, here's the formula. S here is called the semi-parameter of the triangle. That means you add the sides, you get the parameter, and then divide it by 2, not 3. So that's S. So once you have the S, then you can put it in here, and you have an answer. That's a very interesting formula, and very powerful. Okay, so now I want to use, I want to do some of the problems in Newton alpha. So let me get out of this right here. I don't want to do that. Next time we're going to talk about the rest of these sections. So let's do some of these problems in law of sine and law of cosine. A few of them. They're very similar to the ones we just did. It says in this triangle, what are the 2 possible values for angle B to the nearest 10th of a degree? So let's, here we go. Let's make some room. Computer is slowing down. Alright, so let's draw a triangle here. Let's call it AB, ABC. So A is 61 and A is 25, B is 27. Okay, so the question is the angle B here. Well, let's see. We got, so we can say sine of B divided by 27 equals to sine of 61 divided by 25. So that means sine of B has to be 27 times that divided by 25. So let's do that. So let's see. 27 times sine of 61 divided by 25, which is 0.94 something. Now we have to find the sine inverse of the answer, which is 70, so it would be 70.834 or something. Okay, now we have to take that and subtract it from 180 because that's not the only solution, you see. So it would be that angle and this angle. Those are the 2 possible ones. So what is the other one? The other one would be 180 minus this answer. Minus the answer, which is 160, 109 something, right? So now, if you don't consider the roundings, you're going to get 109.2 and 70.8. You have to round to a certain number. Okay, so those are the 2 possible. So in this case, we have 2 possible triangles, right? One would be acute and one would be obtuse. Okay, so let's do one more from this section. And find the side length R. It says law of sine, law of sine. Okay, in this case, the triangle is, let me get a whiteboard here. So in this case, the triangle is PQR. Well, that's okay, we can call it that. So capital R, sine of R is 2/3. So sine of R is 2/3. And and sine of p is 1/3, and p is 9. So p is here, that's 9. So find a side r. So this is r, right? And this is little q. And that's p, which is 9. Okay, so if you want to find r, we can do r over sine r, right? So we can do sine r divided by r is the same as, or we have p, we have sine p, can't write this, sine p divided by p, which is 9. So r is going to be, if you cross multiply, would be 9 times sine r divided by sine p, right? And what is that? Well, let's see. So 9 times sine r we already given is 2/3, 2 divided by 3 divided by sine p, which is 1/3, 1 divided by 3. So that's 18, right? So it should be 18. All right, so that is a law of sine. And the law of cosine, let's do an example here. Okay, it says an airplane started at point K, okay, traveled 560 miles to point L, adjusted its route and traveled around another 575 to point M. If the airplane is currently 952 miles from its starting position at K, by how many degrees did it adjust its route at point L? So what's that degree? Well, in order to find that, we have to find this angle right here, right? Now, do we have enough information to do that? Yes. Which law should we write? The law of cosine, right? So what we have to do is call this, doesn't matter what we call this, but this side right here, squared, right? So 952 squared equals to 575 squared plus 560 squared, right? Minus 2 times cosine of L, let's call it L, this angle right here. So this would be 575 and 560. So cosine of L would be whatever this is divided by whatever all of that is, right? So let's see what we get. So let's find all of these to the, so I have 952 squared, so that's the left side. And then if I add this, if I add this one and this one, right, like this, and then subtract and move it to the left side, I can subtract it from that number. So I'm going to take that number and subtract from it 575 squared plus 560 squared. There. So it would be that number. And then I have to divide that number by minus 2. I have to divide that number by minus 2 times all that. So let me do that. I'm going to divide that by parentheses minus 2 times 575 times 560. There. Alright, so it would be that. Now what I have to find is cosine inverse of that number. So if I isolate this cosine L here, so cosine L is going to equal to negative what? 0.40 something, 0.406. So what I'm going to do on the calculator, I'm just going to find the cosine inverse of the answer. So cosine inverse of the answer. It's going to be 114.01. Now that's what this angle is. Of course, we have to subtract it from 180 to get the other angle. Okay? So, and that would be, well, 66 something, right? So we have to subtract it from, just do 180. 60, if you round it, is 66 degrees, right? All right, so that's the law of cosine section. Now, area of triangles, so we have two formulas to use with that. So remember, if we have two sides and the angle between them, we have a formula. Remember that formula? It was right here. Right there, right? 1/2 BC sine of between them. So we can do that easily. So the angle, this one would be what? This one would be, let's see. So the area would be 1/2, which is 0.5, times 10 times 9 times the cosine, sine of the angle 45. And make sure you're in degree mode for that to work. So it's 31.3, right? That's that section. So I don't want to make this video too long, but next time we're going to work with the other 3 sections, and I see you in the next video. Okay, so take care.